Alright, boys and girls, I am sitting in the alley of some place. I'm getting my car work done, so I'm throwing you guys a little different view of notes for today. This is lesson 4 or 5. Make sure you get the information written down. We're talking about scatter plots and the different correlations that we could derive from looking at the graphs. So as you guys can see, we have a positive correlation, a negative correlation, and no correlation. And it should be rather obvious that a positive correlation generally has an upward looking points on the graph. A negative correlation has a downward looking points on the graph, and no correlation, we can't really see if it's going up or if it's going down at all. So that's information that you want to make a quick sketch for yourself for your own notes here. Alright, moving on. On example number 1 here, a graph shows the average number of students per computer in Mariah's school. We are supposed to determine whether the graph shows a positive, negative, or no correlation. If there is a correlation, we need to describe its meaning. So again, we're talking about the average number of students per computer. So if we look at this information in the year 2000, 2004, 2006, and 2008, and then the number of computers. So students per computer, that means there's, up here we're looking at the 40s, 50s, 60s students for one computer. When we get down to this, we're looking at about 5 students per computer, which means that we have a negative correlation because it's going downward, and that is telling us the meaning is that there are more and more computers, or there could be less and less students. So depending on the way we want to twist this, there could be more and more computers, or there are less students in the building. More computers, or there's less students per computer is the big thing here. Less students per computer, which is exactly what it shows for our y-axis over here. Moving on. A line of fit is a line that we draw onto a scatter plot that's going to be very close to like the middle. It's kind of like our mean or our median of the graph. So it could be referred to as a trend line, a line of fit, a line of best fit. And so here's what we're going to do. We have a table that shows the growth of the world's population, and our job is to identify the independent and dependent variables and then make a scatter plot and determine whether the relationship, if any, exists in the data. So we're going to use a line of fit to identify any trends. So in the year 1650, so these are my x's and the population is my y's. So we know that this one is my independent event, the year is what it is, and the population depends on the year. So this is my dependent event. So 500 million, 100 million, 1,000, 2,000, 4,000, 6,400, or 6.4 billion. And then we're going to take this information and make a graph. So every graph must have the following things: a title, an axis, the axes that are labeled, and then the units. So our title is going to be population of the world. Population of Earth. Our axes, we just said that the x is going to be years, and that the y is going to then be millions of people. I don't know why I put a 5 there. Maybe because I know the first one was 500. So this will be the population. Let's put that. Population in millions. Now I apologize for my handwriting. I am again in an alley while my car is getting worked on. It's kind of weird. So we have to make the units. So we have the years, and we're going to want to probably go up since our years are going up by 200. So the smallest number is 1650, the largest number is 2000. Let's count by 100. So let's call this 1600. Over here, let's do 1700. Over here, let's do right here, 1800. skip for 1900, skip for 2000. Okay, and then over here on the other side we'll put by millions. Let's go 200, 400 million. Here, see, that's not going to be good enough, is it? Because we're getting up there very quickly. Let's just skip up by 500 million. That'd be a better number to get so that we can get the whole graph on here. So you guys see how we're going to need to make a decision here. So this is 500. This will be right here. This one is 1,000, 2,000, 3,000, 4,000, 5,000, and 6,000. Let's take and move some of this stuff. Whoop, out of the way. Whoop, out of the way. And now we can graph these things. So at the year 1650, we're at 500 million. That's going to be right about here. At the year 1850, we're at 1,000. So that's 1850. Right about here, we're at 1,000 or 1 million. The year 1930, we were at 2,000. 1930, probably about here, 2,000. 1975 was 4,000. Whoa, 1975, 4,000. And then 2004, just after this, will be at 64. So we'll call this 6.5 right here. Now, if I were to have a line of best fit, what I'm trying to do is come up with a line that's kind of in the middle. You can see that the line's slowly getting steeper. So if I were to have a trend line, my trend's going to be going upward. It's kind of increasing at a very rapid rate. And I even want to make that more exaggerated probably. See if we can tilt this. Oh yeah, that's better. And what I want you guys to notice is that if we're to make an equation, we can pick 2 points that are very close to the line, because this is what the pattern of the line is kind of following, and we'll be able to then use the slope of those 2 points. So we'll pick those 2 points, plug them into our y2 minus y1 over x2 minus x1, and we'll get ourselves an equation from that specific information. Now that's going to be the thing that I would like you guys to do on your own, because that'll take too much time here for us in the video, and we'll check that answer when we get back to school on Monday. So this is your assignment. Do your best and enjoy the weekend. I guess if you don't watch us until Monday, hopefully you enjoyed your weekend.